Hello, today we will take a look at a component called a servo motor. It is the executive part of a mechanism that has a rotating shaft and allows you to precisely control the angle of its rotation. A servo motor consists of a miniature motor that transmits rotation through a gearbox to the output shaft. The shaft, in turn, is connected to a potentiometer that controls the angle of rotation. The servo motor kit includes the servo motor itself, one small screw for attaching the bracket to the servo motor shaft, 3 types of brackets, and 2 larger screws for attaching the servo motor. 3 wires come out of the servo motor. Brown or black is ground, red is power, and orange is the signal wire, which transmits control commands using pulse width modulation. Even though the servo motor seems small, it is quite a powerful consumer of energy. At startup, it can consume up to 0.4 amps. Therefore, connecting the servo motor directly to the 5-volt pin on the Arduino can cause problems. A sharp jump in current when the servo motor is moving can cause other components to malfunction and even cause the Arduino itself to reboot. Therefore, always use a separate external power source for servo motors. To do this, connect the negative terminal of the external source to GND on the Arduino to provide a common ground. Then connect the power supply and negative terminal of the servo motors to this source. As a result, only the signal wire goes from the servo motor to any digital pin on the Arduino, for example, the 6th. Now let's move on to programming our Arduino. First, we need to connect the built-in library in the Arduino IDE called servo.h. Next, we declare a variable of type servo and name it, for example, myServo. Then, in the setup function, we specify which output the signal wire is connected to. In my case, it is the 6th digital output. Now in the loop function, we use the myServo.write command to control the rotation. And in parentheses, we specify the rotation angle in the range from 0 to 180 degrees. For testing, we will write a program that first sets the rotation angle to 0, then to 90, and then to 180 degrees at 1-second intervals. After uploading the firmware, we can see that the servo motor rotates and changes its position every second. We have just looked at a 180-degree servo motor, but there are also continuous rotation or 360-degree servo motors. The difference between them is that a conventional servo motor has a potentiometer, while a continuous rotation servo motor does not. If, in the case of a conventional servo motor, the line myServo, write and 180 in parentheses, this means that the block will stop at the 180-degree mark, but in the case of a continuous rotation servo motor, it will rotate in one direction at maximum speed. And if we set 0, then it will be the maximum speed in the other direction. And accordingly, when the value is 90, the servo motor will not rotate. Let's not change the program code, but simply replace the regular servo motor with a constant rotation servo motor and compare. Now we can see that the servo motor rotates in one direction, then stops and rotates in the other direction with 1-second intervals. Now you know how to work with regular and constant rotation servo motors. Thank you for watching, and see you in the next video.